Hello everyone and welcome to the lecture Internet of Things. Today I'm going to talk about electronic components. Okay. Until now, we got to know what is PicoW and what is its specifications and pinout diagram. But PicoW is only part of what we will need to begin working with physical computing. And the other half is made of electronic components. The devices you will control from Pico's GPIO pins. So among thousands of different components available, most physical computing projects are made using the following common parts: breadboard, jumper wires, push button switch, light emitting diode, or in abbreviation LED, resistors, and I2C display, sensors, and many other things. So let's see one by one what are these electronic components. Breadboard. Breadboard also is known as a solderless breadboard and can make physical computing projects considerably easier and more stable. Rather than having a bunch of separate components which need to be connected with wires, a breadboard lets you insert components and have them connected through metal tracks that are hidden beneath its surface, as you can see in this photo. I open up this breadboard, and this is the surface of the breadboard, and this is underneath surface. Many breadboards also include sections for power distribution and make it easier to build your circuit. You can see in this photo all these outer parts. They are called outer parts, and the blue outer parts, they are for voltage, and the inner part here, they are ground. So you can see also they are horizontally connected. All of them, they are connected. And these 5 holes in each row are also vertically connected. They are all, if you connect your pins, it will have, all of these holes have the same voltage. So you can see inside the breadboard how it works. We have these outer lines, and we have inside that they are connected like this, and the outer, they are connected like horizontal. Actually, you don't need a breadboard to get started with physical computing, as you can use special wires to connect components directly to your Pico WGPIO pins. But it certainly makes things simpler and more stable if you use breadboard. Okay. The next electronic component is jumper wires. Jumper wires, also known as jumper leads, connect components to the PicoW, and if you are not using a breadboard, connect components to each other. 3 versions of jumper wire jumpers exist, and the 2 most that we use is female to female, F to F, and is used to connect individual components to your PicoW if you are not using a breadboard, and male to male, and it is used to make connections from one part of the breadboard to another part. So depending on your project, you may need all three types of jumper wires. And if you are using a breadboard, you can usually get away with just M2F and M2M jumper wires. So the next one is, okay, this one in this photo, this is male to male. In this one, it is male to female. And this one, it is female to female. So just look at the end of the wire and you can see why they are called M2F, M2M, and F2F. Okay. The next component, electronic component, is push button switch and latching switch. A push button switch also is called a momentary switch, and is the type of switch you would use to control a games console. You have used it for sure, and it exists with 2 or 4 legs, as you can see in this photo. 1, 2, 3, and one there is behind. And both of the type will work with the PicoW. And the push button is an input device. It means that you can tell your program to watch out for it being pushed and then perform a task. When you push it, it will do the task or the code that you are telling it what to do, and it will perform it. And the latching switch is another common switch type, and the switch is only active while you are holding it down. It means that as long as you leave it and release the button, it will be deactivated. So you can find it in a light switch, as you can see in this photo. And the latching switch activates when you toggle it once, then stays active until you toggle it again. Okay, let's see another electronic component that is called LED. LED is an output device. You control it directly from your program. An LED lights up when it's on, and you will find them all over your house, ranging from the small ones, which let you know when you've left your washing machine switch on, to the large ones you might have lighting up your rooms. And LEDs are available in wide range of shapes, colors, and sizes, but not all are suitable for use with your PicoW. Actually, you should avoid any which say they are designed for 5-volt or 12-volt power supplies. Only 3.3 volt power is enough for the LEDs. Okay, the next electronic components is resistors. Resistors are components that control the amount of current that flows through an electronic circuit by limiting the amount of voltage applied to the circuit. Resistors are available in different values measured using ohm unit, and the higher the number of ohm, the more resistant it provided. As the name it shows is the resistor, and if it is higher the value, it will resist more against the current. So the current will be, the flow of the current will be less. So in PicoW physical computing projects, the most common use is to prevent LEDs from drawing too much current and damaging themselves or the PicoW. Okay, it's the let's say it's application of the resistor that we put it in our project, in our circuit, to prevent LEDs from drawing too much current. And we need resistors that is rated around 220 ohm to 330 ohm. And this is the resistor that we have. And now we will learn how we should read a resistor number. or value. So you should read a resistor value based on the color codes. There are as you can see, there are four strip of the colors, and there are also four tables of colors that correspond to this strip. So the first band here, from this table, you should choose the number. For example, there is a example here. It's a 4-band, and it says that you should read it from left to right. The first is that brown, and based on that's first band. It is from this table color. You see that brown is the number 1 according to this color coding. Brown is number 1, so we put number 1 here. And the second is red, and look at the table. Red is code color 2, and we put 2 here. And the third color is green, and you can see green is multiplier. Look at here, the 3 is multiplier. So whatever you have will be multiplied by 10 power 5. So 1, 2 multiply 10 power 5. And the last one is tolerance. How much is the tolerance of your resistor? And in this color it is gold. So look at the table, and the gold is plus minus 5%, and we will put it here as plus minus 5%. So the value of this resistor will be 1200 kilo ohm plus minus 5%. If you another example is that yellow, violet, and red. Let's see what is it. Yellow, the code color is 4. We put 4 here. Violet is 7. We put 7 here. And red is 10 power 2. And we put 10 power 2 here. Always you should know that it is multiplier. That is why we have multiplication sign here. So the value will be 4700 ohm or 4K7 ohm. The next electronic component is an I2C display. An I2C display is a screen that talks to the PicoW over I2C bus. As I mentioned in the previous lecture topic, we see that how LCD display is connected to PicoW through I2C and SPI, both of them. I2C bus lets PicoW control the display panel, as we see in the previous session, and sending everything from writing to pictures for it to display. One popular display that I wrote it here is Sir LCD, and it's manufactured by SparkFun, and it has two I2C and SPI interfaces. And Sir LCD can display 2 lines, each with up to 16 characters, and it is a useful device for outputting bits of information about our system. But note that some displays only use the serial peripheral interface and rather than they use I2C. So they will still work with your PicoW, but need the program to be changed. So you should notice that every devices are not provided in every digital communication protocols. Okay, the list of necessary hardware that we will use in this course, it's mentioned here, and is a Raspberry Pi Pico W with male headers attached, and they should be for sure soldered, the Pico W, and a breadboard it should be large enough to accommodate the microcontroller, I mean your Pico W, and the sensors, and the micro USB cable you will need, and micro USB cable, if I want to show you, is this one. You can see here, and then a male to female. This micro USB is this side is USB, and this side is connected to your Pico. This side is connected to your computer, and this side is connected to your Pico, and then you can do programming on that. A male to female M2F and male to male M2M jumper wires, and the Raspberry Pi or other computer for programming, the Raspberry Pi Pico W. It means that you should have a computer or a host computer, we call it, that you need to install your integrated development IDE that install the softwares that we need to develop our Raspberry Pi Pico. So it can be a Raspberry Pi, or it can be your computer. That the best option is that your computer, and I will show you how you can install and do the programming. And LEDs and if you are using LEDs, the resistor should be 220 ohm or 330 ohm for each LED. And if we are working with the temperature sensor, and the temperature sensor, it will be DHT11 or DHT22, and 10 kilo ohm pull-up resistor we need for the temperature sensor. And the other project-specific sensors, if you are working with some stuff that, for example, it needs driver board or, that you need to prepare. For example, let's here, this is our LCD. But what if some devices, I mean LCDs, they don't come with the needed drivers? For example, this LCD, if you look at it, it doesn't have I2C or SPI. Then in this case, we need a driver board for it, that it has I2C and SPI. And these two will connect it to each other. Then we can send data through I2C and SPI to our LCD. You can see here we have ground, VCC, STA, and SCL. That it shows that we can work with these protocols. So, but let's see what is soldering. If your Pico W is not soldered, so you need for sure to do soldering for that. I wanted to show you that, okay. Soldering is a process of joining metal components together using a filler material called solder, which has a lower melting point than the metals being joined. You should always be careful that follow safety precautions, and why we need it is that without soldering, you cannot do much with the Pico W. It's not possible. And without soldering, you can download programs to the Pico W, flash the onboard LED, and send data back out of the USB port to the host computer, I mean your computer. And you can do these things, but even to just debug a program, you must do some soldering if you want to do programming or do debugging. And the easiest way to set things up is to solder a set of pins to each side of the board. And in this case, it can be inserted into an electronic breadboard, which then allows us to connect things up without further soldering. But if you want to know how to do soldering, there is a very short instruction for that. And you can, first of all, you should hit the pin and pad. This is the pad, and this is the pin. And add a little solder. Here we are adding this solder, and then remove the iron. And then a weld solder pin we have, but it's not so easy as you see here. For knowing how to do the soldering, you can follow these following links, and they will show you how to do soldering. And I brought this warning here because it's very important that you know, soldering is not toys, and they get very, very hot and stay hot for a long time after even they are unplugged. And if you are a younger learner, make sure that you have a supervision. And whether you are young or old, make sure that you put the iron in the stand when you are not using it, and never ever touch the metal parts, and even after it's unplugged. So you can follow these two links if you wanna soldering yourself. But some soldering examples of error I brought here that you may do these soldering problems as well. And for example, let's see the picture A. The solder here is sticking to the pin, but not sticking to the copper. The pad is not, as you can see, is not stick to the copper pad, and it's sticking to the pin. Then the pad wasn't heated up enough. This is one problem. And the picture B, if the solder is too hot, it won't follow well, and you'll get an overheated joint with some burnt flux. In this photo, see, if the solder is entirely covering the pin, which means you use too much. You use too much solder. And photo D, if it is touching other pins and they are connected, and you have created a breach which causes a short circuit. And and in picture E, if you can still see copper pad, or there is a gap between the pin and the pad, which isn't filled in with solder. So you use too little in this case. It is too much and it is too little. And the best case soldering is this one. That it shows that how well it is done. Okay, it's the end of the lecture, and thanks for your time. If you have a question, please Slack me and on the groups that we have on Slack, and or you are very welcome to the lab.